Hello everyone, I will be talking today about the singleton pattern, not only on code, but also at architecture level. I will be really trying to explain the concept of the singleton more than how to implement in language. I will show you how to implement in Java, C Sharp, and Python. They use different ways. C Sharp is very similar to Java, but Java also has some variations. For instance, as you know or not, but Java, for instance, has a great rich implementation for enumerators that you don't see in other languages. And you can use that, for instance, for the singleton pattern. In Java, I think I will provide you 5 or 6 ways to implement this pattern. I'll provide you one in C Sharp and another in Python, which use metaclass, something that I don't usually see in other languages. And I think it can be a new tool that you can use if you don't know about it, of course. As I was saying, it can be a good tool for you to use on your daily professional life. It's a different way to see classes. Then I will analyze some pros and cons about the singleton, the relation with the singleton, the solid principles, which is something that we always should do regarding the code. That's when we have a pattern or an idea, let's compare it or let's challenge this concept with the solid principles, which are solid, as the name says, but of course they are 5 principles that we should consider every time we are designing code. And of course, I will talk about alternatives to singleton for some scenarios that at first seem that singleton it's a good way to go, but sometimes there are alternatives that are better depending on the use cases. So let's start. So what are design patterns? Design patterns are at the end of the day just reusable solutions to common problems in software design. It's not that you develop patterns, but usually you have I would say, two advantages when you understand about patterns. First, it's because it's a reusable solution for specific problems. There is already a good way to go, and we give it a name, which is a pattern. And singleton, it's one of them that are factory, abstract factory, composition. There are a lot of them. There are dozens and dozens of patterns. People sometimes say there are 23. Okay, these are the gang of 4 ones, but it exists dozens of them at the architecture level, software engineering, and even on management. In case you don't know, there are also patterns regarding management and activities that you can do on your project, in DevOps, continuous integration, continuous development. There are a lot of patterns. But at the end of the day, they are just good practices that works in most of the most important scenarios, and we give it a name so we can share this knowledge with the other people just using by name. They are not concrete implementations, but they work as a kind of a template, not a code template, but let's say in our mind, it's just a template that we fill with other names and we'll adjust to our use cases. And promote good practices, reusability and maintainability. Be careful with this good practice because there are also anti-patterns, meaning that sometimes the use of the pattern constitutes an anti-pattern, meaning if you choose the wrong pattern, you probably your solution can get worse than better. But there are several categories. Now I'm targeting the code. There are other kinds of categories when you are not talking about the code. One of them are creational. Mainly it's patterns on how to create objects. At the end of the day, people think, okay, create objects just a new, but not. Maybe you want to put some rules like I only want one instance, which is a singleton. For instance, I want to create an object, but it depends on the parameter. So you have the factory method. There are a lot of different ways, different patterns for different use cases, and when is the behind the of what we want, it's about creation of objects. These patterns they are included in the category of creational. There are others patterns more that target structural, meaning that they deal with how classes and objects are composed to form larger structures. For instance, composition. Sometimes you have to create something like a file system, so you have folders and items. So you have patterns for that. Of course, there are other patterns with different compositions, but it's about the structure of the objects, meaning that you want to structure something, and you should look for structural patterns. You are not. It's not creating. It's about how do you organize the relations between your objects. And in this case, you are looking for patterns in the category of structural. And there are others called behavior that are concerned with the communication between objects and how responsibilities are assigned. And I can speak some of them. For instance, imagine you want to create a chat application and you need something to notify other objects. It's not how you structure the classes. It's not about creation of these objects. It's how they behave. Where should I put these objects so I can receive some messages and broadcast them for other objects? So now you're talking about flow, about behavior. And that's why it's quite popular to say that usually the three main categories of design patterns that targets the code development are creational to create objects, structural when you want to create objects but within a specific structure, like for instance a file system where you have folder files and things like that, or maybe an organization like departments, employers and employees and things like that. And behavior when you need some behavior that it's popular, it's a pattern, like there are a lot of places where a lot of solutions where you want to send a message and then you want to target one or two objects or all of them. And this can be messages, can be a lot of different things. So this is the behavior category. So the singleton pattern, of course, it's a creational one because it's about creating an object and we want to create a specific rule, which is ensures the class has only one instance and provides a global point to access it. And sometimes we want this. For instance, if we have a global configuration for an application, we don't want to allow two instances of this class, because at some point one of the class will receive some values, another class will receive other values. If you are, for instance, in a multi-thread environment, and when you get a configuration, you don't have a source of truth. And that's why the singleton pattern, it's a quite good addition to the patterns, and it's probably one of the most popular patterns that you have to understand. Probably, I think most of the course starts with the singleton pattern. It's simple and it's quite useful. So it deals with object creation mechanisms, trying to create objects in a manner suitable for the situation. That's why it's a creational pattern. Key principle, just one. That's the main idea, just one instance. And now it's how can you develop code to make sure that only one instance of a specific class exists. And of course, the first tip that I can give you should block as much as you can the new. You cannot allow any class to use the new keyword if you are in a class like in a language like Java or C# or similar. You cannot allow it. If you allow it, then you cannot assure that you have only one instance. So it should be private. And now from this one, you start to guess how to implement this kind of pattern. So why use singleton? Controlled access to a single instance. The idea is just to prevent multiple instances. It's by definition. Reduce resource consumption, for example, cache configurations and things like that. Connection pools, database connections, logging, system log is just one through all the applications. You don't want multiple instances of a logger. Global point of access for configuration, for instance, and centralized management, useful for managing shared resource or configurations. If you think, for instance, authentications, authorizations, things like that, you can see a lot of use cases where singleton makes your life easy, and more than that, it's not making your code simple to develop, it's to make sure that it's reliable, your code, because you are sure that when you call that specific entity, it exists only one and it is the source of truth. So the user is authenticated or not, and you trust the code that you call that method and say, yes, the user authenticated, because you know that there is no other instance that can also do the same thing. That's the most important concept and usefulness that you can give to the singleton. So when do you want to use it? Logging, configuration management, as I was saying, database connection pools, prints, pullers, registry settings. There are a lot of scenarios. At the end of the day, you just want a source of truth, which means that you only want one instance. So usually in a simple implementation using UML, you have a class, let's call it singleton. You have a static because you want to guarantee that you only have one, and you want the constructor to be private. So the only way to create this class is through a static method that insides can use the new keyword and call the constructor. Because if you put a constructor private, it's not that it's impossible to create a class. It means that the class can only be instantiated, since it's private, by methods inside that class. So if you create a public method that which is static that creates the instance, it's inside your class, so it can access all the private methods. and the one that you want, it's the constructor. So you can call it and you can control. After you create it, you can say, okay, I will put instance in a variable, call it instance, and if it's null, I will set it. If it's not null, I will not create the instance. In this way, you are sure that you only have one instance. You are sure-ish, as you will see, because when you are in multithreading, you cannot guarantee that unless you provide a mechanism to block other threads to do the same thing. Because I don't know how much good are you in multithreading and parallelism. When you have a statement in Java, it's not singleton. For instance, something simpler like a long variable called high equals 5. It's not one statement behind the scenes on the byte code of the class, meaning that when the thread is executing your code, you will not see one statement or one line like I equals 5. You will see something like 5, then you will see another which is high, and then you will see the assignment. Maybe there is 2 or 3 lines behind the scenes. And it can happen that 3, 4, 5 threads, all of them read the I at the same time, but all of them are paused. Now the processor gives to thread 1 to follow through, then the second one, but all of them, they receive the same value. So at the end of the day, if it was a check, for instance, if it was null, it can be the case that all of them thinks they are null and all of them will create an instance. That can happen, and if you develop code for that, let's say put 1000 threads in your Java, don't provide any synchronizer, nothing like that, and try and you will see how much instance can you create even if you test with just a singular if to test for null. And you will be surprised by the results. Sometimes when I do training about this kind of concurrency and parallelism, I show this and I provide a kind of a validation to say if it's less than 0, don't enter in a cycle. And sometimes it enters because I decrement the I in other places. And when you have enough threads, it will break your code. So be careful with concurrency issues. So in this case, we have the instance with a private static, constructor is private, and the only way to access the instance and constructor is through the static. So you put all your control here on this get instance in this method static here. And then you have operations that they don't have to be static because you'll return an instance where you can get values, set values, and things like that. The purpose of the singleton. So the structure of the singleton is a private constructor, private static instance variable, everything is hidden, but you have a public static method that will work as a kind of a gateway to access the singleton instance. And here you can work the code the way that it fits better to your solution. But you will see some examples in a moment. So implementing strategies, there are a lot of different strategies. I will target Java, as I said previously, because you can see, maybe it's the richer place for you to find different approach to the single pattern. Other language, they also have their own ways to create singletons. For instance, Python uses a different one. There are several ways in Python, but I will show you one that is completely different from these ones that I will show in Java. Well, let's see, so you can learn from it. So eager initialization, meaning that I want to instantiate as rapid as possible the instance. There are others like lazy initialization, and in this lazy initialization, you have 2 ways to implement it. One is the thread safety, the other is double check. This is probably one of the safest one. Then there is one common and popular that sometimes it's used even, it depends on the idiom, but I will see the details, I will not explain it here, which is called build bug singleton. And then you have the Enum singleton. And I will provide different ones, for instance, in Python that I didn't put here on this list. So let's start with eager initialization. So the concept that the instance is created at the time of the class loading. Remember that when in Java, when you have a class, everything that it's static, it's executed when it's necessary, meaning when you can have static classes in your code. And if, for instance, you need to use a specific class in your code that reference something in a class and that class use some static values there, these statics first are loaded by the class loader of the Java virtual machine. So the class will, let's say, fits the requirements to be instantiated and used. What I mean is Java doesn't load everything, all the packages, everything that you have in memory when you start the application. He has a clever system. But for the static ones, every time it detects that it will be necessary directly or indirectly, it will load them. And for instance, you have a static variable that is associated with the new will be executed even before you use the class. And this is one of the eager initialization. So the advantage is it's simple to implement. It's thread safe by default because you load the class, it's already there. The instance is created even if it's not used. Of course, if it's just a low resource, it's no problem. But if we are talking about cache and things like that, maybe we don't want an eager initialization. Let's see how it works. So this is an example of a class. We have this static here, and you can see this static line as this new. So when this class is loaded by the Java virtual machine, this constructor will be called. Sometimes you want and sometimes we don't. Well, what I mean by this, imagine that you say, okay, I will use this one, it seems very safe. But imagine this instantiation needs to load resources that when the class is loaded, they are not yet initialized. Because maybe the use of this class, it's after your system is initialized. That's when you start to use the methods of this class. And then you can have a problem because you have precedence on the classes. So it's a solution if it's a simple application, but be careful. What are the requirements here in the constructor? Make sure that everything that you will be doing here in this initialization, it is already ready to be collected or initialized when the application is started. Sometimes they are not. Maybe you want to connect to an external system, or maybe you are waiting for a file, and then you will be waiting here and here until you have that, and the Java will be waiting to call this constructor. So you have always to think about these side effects that when we think about a solution, say, okay, this is the best one, but sometimes it's not when you consider all the other requirements of our application. Of course, we have also the lazy initialization that tries to resolve these kind of issues. So the instance is created only when it is first requested. So it's resource efficient, and the instance is created only when we need. Of course, it's not thread safe now by default because it will be on our responsibility to control the threading. The previous one, it will Java, its application is starting, so there is no threads running, only one it will create, and that's great. But if it's lazy initialized, it can be the case that you start your application and only 5 days this constructor will be called, and there will be probably many threads executing that are competing for this resource. And in this case, you have again the static because it belongs to the pattern. But now you want to make sure that you test if it's null. So if the instance it's equals null, because it will be our responsibility to make sure that it's created. So you have to test if it's null, how you will create it. Otherwise, you'll return the one that is there. So you assure somehow that you only have one instance. But the problem is, at the end of the day, you will never have more than one instance. The problem is that if you have multi-threading, can be that multiple threads can call this line. It seems strange, but it's possible because remember, the threads don't see this as one line. There are several lines in bytecode to support this statement here. Because one line should be to put the null in specific place if you know machine code. Then this is a variable that is referenced. Now you want to compare and check if it's true or not. So you have several lines just to make sure this works. And then this will be executed. And all these lines can be shared and preempted by the processor regarding threads. So at the end of the day, you can have 10 threads and the latest thread be the one that really set the instance. In this case, there will be no problem because you don't have any attribute special, but imagine that it's initialized and there is some parameter that you want to pass here, and it's important, the first one that arrives, then you can have a problem. Thread safe lazy initialization. So in this case, we will take this example and we'll try to fix the thread mechanisms here. So in this case, it's the same concept here for the static, but here we use the word synchronized in Java. And this makes sure that only one thread enters here. So now we are sure that only one thread enters here. So if the instance is null, then instance new thread safety, and it's set, so it seems great. So the other threads, all of them will wait here. Sometimes people say it's not a good solution if it's an object that is highly used at first, because it creates a big queue of threads here just to check this. But in that case, make sure that you are designing your application correctly. If you are putting a lot of processing depending on something that should be synchronous, like a singleton, maybe you should think about maybe create a kind of classes that are read-only, meaning that you instantiate them and you can have multiple copies, or you can clone them and give to the other threads. That's usually an approach that it's possible to be implemented. Sometimes people say, I will have a singleton, it's just read only. In those cases, I don't know if it's the best thing. Maybe you want to provide a set of instance, and every time a thread needs one, just create one, put the values there and return it. So you will not have any concurrency issues because it's always a new instance for each thread. I'm not saying that's the solution, but it's just a tool that you can use. And in some scenarios, it's better than have a singleton. To avoid some these issues about performance and concurrency, there is something called the double check locking. And the double check locking is quite clever because rather than have a singleton, all the threads blocking here on the static, I just let them enter on my instance and I will test. If it's already initialized in the past, okay, just return the instance. There is no reason to synchronize the threads if it's not null. But if it's null, now you want to synchronize. So you are making sure that it only blocks if it's the first time that the singleton is being initialized. But there are some issues here on this instance equals null and the way the Java generates the code. And that's why we have to use this word here, volatile. And I will explain in a moment what it means. But first understand what is the advantage of this one over the other one. It's the threads don't wait when they call the get instance if the instance already exists, because it will be different than null. So what happens here? So if instance equals null, skips locking if it already exists. That's one of the big advantages. So on the step 2, which is inside, which means it was null, the instance here. So prevents concurrency initialization. Of course, that's the main definition of this word in Java. And second, the second instance equals null guarantees only one instance is created. That's why it's called double checking, because even inside we still put this equals null. There's some reasons for this to exist, because there are history behind this, behind the Java, and this approach just it's the most, let's say, reliable one if you follow this simple approach for this pattern. And of course, you have the instance equals new singleton to create instance. But let's talk about the volatile, this keyword in Java that sometimes people don't understand. What it means, the volatile keyword in Java assures visibility and ordering or variable updates across threads, meaning that when you have this volatile on an instance, every time that something wants to change this in a multi-thread environment, it's like as if Java put a kind of a concurrency over this value. Say, okay, I will generate a set of rows or internally, not your Java, but the ones that really execute your code behind the scenes, and I will make sure that the sequence it's the same for all threads, and all the threads know that I'm putting this order, that a thread it's already reading this instance, or this, not instance, it's the name of the variable instance. So the volatile keyword in Java shows visibility to the other threads and ordering or variable updates cross threads. It's used when multiple threads read write the same variable, because as I said previously, one statement in Java doesn't mean that it's one statement for the threads. Sometimes there are multiple. And when we are reading or writing, there is a sequence of statements that will be generated. And the volatile assures that the other threads follow the same sequence. So it's reliable. Otherwise, it can be a problem. So there are three things that are guaranteed by volatile. So the visibility, it's the most important one. Change made by one thread are seen by all the threads, meaning if one thread puts a value in that variable, all the threads will see that value there. It's a kind of a mini atomic, let's say, transaction on that variable. It's too strong what I'm saying, but it's for to make sure that you understand better this concept. The reordering of the rows that are generated, so prevents the Java virtual machine and CPU from reordering reads and writes around the volatile variable. So all the threads will use the same sequence, meaning that it's reliable, the synchronized and everything that you have on your code, meaning that when you test, for instance, here, the instance equals null, all the threads, they are using the same sequence of statements that are generated. And atomicity, as I was saying, like a mini transaction, it's not guaranteed, but it works for a single read-write, not compound actions like count plus, because it seems like it's a statement, but behind the scenes, this is not a statement. This is a variable count that needs to receive another variable called count, which is the same one, but for the code generator, it's not, and another value, which is 1. So there are a lot of statements is that there will be no atomicity here. It will be if it was count equals 7. In that case, we can guarantee atomicity with the volatile here. But for this is not, it's not atomic because there are more than one operation here. There is a sum and an assignment. It's two different operations. So usually this volatile is used when we want to set values or read values, not operations on that. For that, you need to synchronize. Use it for flags, state changes, or save publication, for instance, like the Singleton pattern. Why is it necessary? Without volatile, this can break due to instruction reordering, because it may be reordered internally, like allocate memory, because it will allocate memory, assign reference to instance, and run construct. You can see that we see just one line, but internal 3 lines. And when you use this volatile, it will make sure that the sequence is always the same for the other threads. So regarding race condition risk, another thread could see a no null instance before the constructor has run and use a partial constructed object. Remember that what's happening here, allocate, assign, run. There are 3 things, and one thread can be on step 1, another on step 2, another on step 2, and more threads on step 1, and you don't know which one will go next. So you can have several of them allocate memory, but you want to make sure that only one then assign. You don't want the second thread to assign the same thing, because they are different, as if this row has 3 rows here. This statement generates 3 different statements. And if you remember, you can have multiple threads here, multiple threads here, and multiple threads here. It can be a problem. That's one of the reasons to use the volatile and to synchronize when it's necessary. This is rare, but real and dangerous multi-threading bug. That's something that exists, and volatile, it's the word to use. So what does it guarantees in our case, in our single instance? Instruction reordering and visibility issues ensures that fully constructed objects is seen by all threads, meaning that when it's created and set, when you create and set the instance against the visibility, a second thread or third thread will see your instance. Even if they created one, it will not be set by them because it was marked as volatile. Okay. So in summary, this double check locking, which is quite important, and there are other languages using this pattern for the singleton. The first null check avoids locking overhead post in it. Synchronized block ensures one thread creates the instance. Second null check, which is inside the synchronizer, prevents double initialization because of volatile, and volatile keyword prevents reordering and ensures visibility regarding the instance. Okay. Another way to create this pattern, execute this pattern, or implement this pattern to be more precise here is build plug singleton. It uses an inner static helper class to hold the instance. This leverage Java close sliding mechanism. It's very similar to the one that we saw where the instance is created, but this one it's a little more clever because it creates an inner class. So it's thread safe, like the one that we put static equals new the singleton, but it's lazy initialization because we are not assigning directly to the instance, but we are creating an inner class to this, and then inner class will only be loaded when it's necessary. So it's a kind of eager, lazy, thread safe option, let's say. So there is no reason to do synchronization, and it relies on the Java virtual machine loading mechanism, which blocks all the other threads until the class sits on memory. So you have a free synchronized way to do things. So you can see this implementation. You have the constructor private, and now you have this inner class, previous static class singleton helper, that this class creates this instance. It's not this one, meaning when this class goes into memory here, there will be no execution of this instance. It's when this class is instantiated, then the instance will be created. And in this case, we just return singleton helper instance. So because it's already initialized by Java. It's very similar to the first case, but it's more clever because it relies on the Java virtual machine loading here, and it will be a kind of a lazy initialization. But because this class can be necessary, but this one, it's only when we need this method, this will be executed. The enum, it's usually called the perfect one. Although there are some cons against it, but it's very pure, because the definition of an enumerator in Java, it's when you define enumerator, the values that you put in enumeration, they are already singletons. It's like Java already provided you the implementation of the singleton. So the concept is to utilize the Java enum type to implement the singleton pattern. So it's simple because it's out of the box. You don't have to implement nothing. Of course, you need to implement the methods that you need to get information from your enumerator. It's guaranteed thread safe by Java Virtual Machine because it's the native implementation of the enum, and the enum by default it's already a singleton. Okay, and then it's resistant to reflection and serialization issues. Of course, it's not suitable for lazy initialization because it's not the definition of enum in Java, and is limited extensibility if you need to inherit from other classes. But apart from that, it's a kind of a perfect implementation of the singleton. So it will be something like this. So this is the instance, and that's it. Of course, you need to provide here methods that you want to access for this instance. And what is great about this is you can implement, for instance, 2 or 3 different singletons on the same enum singleton. If you want to provide 2 or 3 different instances with different purpose, you can use the same enum somehow. It's because you can even pass parameters here, but that belongs to the theory of the enumerators in Java. It's quite powerful, the enum in Java. In Python, there is something. If you don't know Python, maybe you don't, maybe you do, maybe you don't. So I will not go into too much details, but I like to explain how it works, the concept. So imagine that you want to create this singleton to call this class. You want to make sure that it's singleton, and that S2 will receive the same instance as the S1. So here people think it works like Java, but it's not. This is the class that you want to create. So you can see that you don't have here private things and things like that. So it's a different approach. You just have the init, which it's executed when your application is created. It's like the constructor, and you have operations. You have nothing here on the class, which is quite strange. How do you guarantee just one instance without providing any code here on the single itself? Remember, this is the class that we want to make sure it's one, and it used this mechanism called metaclass equals single meta. And in Python, I will not go into much details here, but you have 2 concepts. One that probably you know, which is inheritance. So you can put a class that inherits from another class, which is not the case here. And you have something that is called metaclass. A metaclass, it's a class about class. The name is already saying about it. So you can use this class that you put here as a kind of a factory to create this class, meaning that every time this class should be created, the creation will be delegated to here. So this method calls will be called, but every class in Python works like that. And even when you don't say nothing about it, all of them, they use this type, and this type, it will be the meta class for all classes, including this singleton meta. The single meta is something that we will be implementing. And we say, okay, of course, we need the type to create one singleton meta, but it will be created automatically by Python. But let's focus here on the singleton. But maybe you want to read more about this. So when you do this instance, Python will look into this meta class and say, okay, I will call this method call, and I will provide here on this CLS the name my singleton, which is the class that you want to create. And now I have this hash map here. Let's say map. Hash map, maybe it's too strong, and you say, is this class already here? No. So I will create an instance, and I will call this super from this method type, so it will be created as usually all the other classes are created in Python, and I will put it here on this instance here, and if it's already there, I will just return the instance that it's there. So it's like as if you have a map of the instance of the class that you created that are using this meta class. But you can say, okay, but the question here is, I'm putting the instance here. So, but this class doesn't inherit from this one. So what happens when I do the second one? Okay, but that's the same concept. it will check here on the instance and will receive the instance. So this guy is returning the instance, so it will return. This is the line that will make sure that this init is executed and the instance will be set on this S1. So the second time that it's called, I will say I want to create an instance of this. It go to this metaclass. I will have the CLES, which is named by Singleton, and we'll check CLES. It's not here. No, that's false. It is here. So return CLES instance to this one. And okay, it will return the instance. So the S2 will receive the instance that exists here. That, and of course, remember that the instance was created on this line in this way. But at the end of the day, just call the parent and the call, because remember, this is metaclasses, which are the factory of the classes. They are not parents. It's strange to think like that. They are not parents. Inheritance is a completely different thing. This is a class of class. Let's call it a factory of class. It's not 100% reliable saying it's a factory of class, but it's factoring class. So somehow we can call it that, but it's a class of class. That's why it's called metaclass. This is a different concept. That's why I wanted to show you where you are delegating to another place the creation of your class, and you use a map to make sure that instance of that class already exists or not. One great thing about this is that you can have a class that can manage all your singletons of your application. I don't know by heart where this can be useful. I never use it, but I like the concept, and okay, why not showing it a different way in a language that people think it's just like the other ones, but it's scripting, but it uses a completely different way of creating objects and managing the instance of the objects. In C#, you can see that you already know this one. Rather than synchronize, they have something called lock, and you can see you can create a lock object like this, and you just use it. It's very similar to the synchronize in Java, but you can see we are using the double check here with the same consequence and the same approach. So that's one way to use it. It's very similar to Java, and it's quite popular to see this implementation when we use C# because it's high reliable. We don't use enumerators because enumerators in C# are not the same as in Java, for instance, and this implementation is usually the most safe one from all the others that we saw. From the architecture point of view, where is the singleton pattern? Of course, centralization configuration service. Every time I develop microservice architecture, and even with it's not microservice, maybe it's a monolith application, but I like to provide, let's say, configuration outside using a REST API, or maybe you have a Redis cache and things like that, that they work like a singletons. They are components in your architecture that will be accessed by other components on your solution. So they are the singleton, they are using the singleton pattern on your, and of course you must be careful how they are accessed to make sure that you can manage multiple concurrency when receiving data. Maybe you want to create a map, maybe you want to prefix the properties of the component that it's accessing or the service that is putting or setting values on your service or central configuration. Logger facilities, center log. No, it's not the logging inside your application, but outside log application. Sometimes you need a central place to send all the logs and ask questions about it. For instance, cache manager. There are a lot of cache managers that work outside your application, and of course they are singleton. That's why they are cache. You don't want to distribute the same values in different cache because it will be a nightmare when one of them change, and you have to provide a kind of a broadcast to make sure that all of them change at the same time. And event bus and message brokers, they work also as a single points of truth where you put messages and all the other systems can read from them. That's where again where you have a kind of the singleton pattern, and it's interesting for you to see them as a singleton pattern because the challenge that you have in the code, most of them they are already there, and in this way you can understand why some options and some mechanisms and some initializations and flags and configurations exist. Most of them are to avoid the same problems that you can find when you try to implement the singleton pattern in the code. This is one example. Imagine that you have a microservice architecture and you have an application model 1 or model B in different applications, or maybe inside an application, and you have a configuration manager. This can be just class accessing class, or it can be different service. It works the same way, and sometimes you just have to access here. Okay, most of the times you have this key but I have seen sometimes some variables here like who is calling me, which is the model, and I can provide a kind of a parent to the key. Sometimes you prefix with the name of the model and the dot before the key just to make space work like a kind of a package or namespace for the configurations. GUI team manager, it's another approach. Usually team managers in applications, single page application, things like that, they work as a singleton pattern. Also, there's a place where you can get configurations about the team that you want to put in all websites, all applications. Sometimes it's indirect, it's not an implementation. It's just a single point of truth where you get specific CSS and things like that. But at the end of the day, it's a singleton that you want to be sure that it's in one place, and if you have to distribute, make sure they all use the same version. Thread pool management, you see this a lot inside and outside applications. In Java, for instance, and other languages, most of the languages, they have a kind of executor sometimes with other names like thread pools. And they are, of course, from the software design, a singleton pattern because they allow to control. For instance, you can have a thread pool that say, I can execute 100 threads. Even if I receive 1,000 requests, all of them should wait. It's like they try to get an instance or a slot to execute. So your instance is to managing these threads. You have a method that internally has, let's say, 100 slots where you can put threads to execute, and you are managing which ones are empty. So the next threads or next executions, they can, let's say, not rent, but book a slot to be executed for your operations. In Java, you can see a lot of them. In C# and language like that, almost every language that support server mechanisms, usually they have this kind of a thread pool management. And at the end of the day, it's a singleton pattern. And it should be because you want to control the submission and the end of the thread. So you allow other submissions only have slots available to execute other threads. Centralized security context, authentication, and authorization. Of course, this one it's quite easy to understand. It should be a single source of truth inside the outside application. Inside, if you use applications like Spring Boot or others, you always have a kind of a model which is authentication and authorization mechanism. And the source of truth, most of the time they are static methods to say, is this user logged in? It belongs to this role. And then which is outside, I can give you a simple example, an SSO that provides authentication, use OpenID or OAuth or something like that, like Google, for instance. Of course, it's a singleton pattern because it's just one service that is serving every other system. You can have more than one. Of course, internally you can have clusters and things like that, but they work as one. Device abstraction layer, it's when you have embedded systems. Of course, the driver should be unique. Again, another sense of truth. I'll not go into details, but it's just another example where you can see the singleton pattern. And these are the examples that I want to show you. So I want to show you the single pattern from the code point of view and the concepts and the challenge and how it applies on the architecture. You can see the same concept and you should be aware of the same challenges about multi-threading, who can access them, when can access, so what should I do when all of them try to set and get the same names. It's important, or the same values on the same properties and things like that. So pros of singleton: guarantee single instance, global access point, for instance, an SSO, thread management, cache, and so on. Lazy initialization potential. Sometimes it's one possibility, sometimes it's not. Centralized resource management, ideal for managing shared resource like database connections or log files. We see this a lot. And configuration flexibility can be configured at runtime. That's one advantage of the singleton. Of course, there are a lot of challenges. Global state, it's something that it's always a challenge because there is a lot of tight coupling and making tests difficult. You have a lot of classes and systems depending on this one, and this can be a real problem. What if it fails or he has a bug? It's a big problem. Testability issues. Usually singletons are not great for tests. If it's a simple values, that's okay. But if the singleton connects to external systems, it's very difficult to mock these dependencies. It violates the single responsibility principle because it does everything. It initializes, controls values, everything. That's one of the problems of the singleton. Hidden dependencies, you don't know what's happening inside the singleton, and you should know because there are implications when you need to access data. There are methods, imagine that depends on an external system that sometimes fails or waits 30 seconds for before failing. It's something that you have to consider. Sometimes you have mechanisms like circuit breaker and other patterns to help on this, but you must be careful about the use of the singleton in these scenarios. Concurrency issues, of course, we talk a lot about it. That's one of the big challenges when we are using the singleton pattern. And of course, refactoring challenge. It's not easy to refactor a singleton. It's nothing easy to do that. If you have a big application with a lot of models and class depending on the singleton, it's very difficult to refactor this kind of code. The relation between singleton and solid principles usually violates the single responsibility principle because it has at least two responsibilities: managing its own instance and its core functionality, and other functionalities that you put it there. And you don't want to spread this functionality because it will not be a singleton, right? Open-close principle can make it harder to extend or modify behavior without changing the existing code. Least common substitution principle in interface is not a problem because there is no interface involved on the singleton. There is no reason to put an interface on a singleton. And dependency inversion principle can violate this principle as class directly depend on the concrete singleton implementation rather than abstraction. Meaning you cannot replace, you cannot say to a system, please give me an instance, and by default it will give you a singleton, but this singleton. Of course, if you think about Spring Boot, by default all the instances are singleton, but that's the scope. It's not the pattern per se, because you can see singleton in different ways. You can see singleton for states like configurations, that we are talking about, but you can also say singleton for class that don't manage state, like controllers, services, repositories. They only have methods to do something. In those cases, the idea of the singleton is the scope, not the behavior. It's not, let's say, it's like you have two patterns. One, it's a creational pattern, which is the singleton, and you have a behavior singleton, which is used, for instance, in Spring Boot. At the end of the day, both are singletons, but they have different purpose. So we should take this subject with in a more, let's say, sensible way and understand clearly when we have a singleton for state, for configurations, which have values inside. So we want to control the threads access, and singletons when they are only methods without state. There is no reason to block threads because there will be no sharing state between the threads. Alternatives to singleton: dependency injection. It's probably one of the most popular. Of course, it's not that you can just replace a singleton by a dependency injection, but for instance, if you are using a Spring Boot, you can avoid the pattern singleton and ask for Spring Boot that it's based on dependency injection to create a singleton for you as a bin, and it will be more clever than any developer to manage the access to the code. Factory pattern, it's a way to create instances based on parameters. It's not a big alternative, but in some scenarios, if you think that you can have multiple instances, because if you pass a parameter, the values that you want to access will be different, maybe it's a way to go. A service locator, which is a very, I wouldn't say it's an alternative to dependency injection. It was the same way, centralized registry to locate services, like a map. The service locator, it remembers most the implementation that for the pattern that I show you in the Python example. Model level globals, again in Python has these different mechanisms to this metaclass that can help to implement different ways for the singleton, and static classes for utility class with only static methods and no instance state. Static class, I don't think Java has static class, but for instance C# contains static class that you can use, which are always loaded when the application starts. So when to reconsider singleton? When you need more than one instance, of course. When testability is really, really important. When you want to avoid global state and tight coupling. When the class responsibility becomes too broad due to managing its own instance. That's, if you are within one of these four, think differently, try to use one of these approach or uncheck these cons and pros that we saw earlier. So in conclusion, singleton pattern is powerful to ensure a single instance. That's the main purpose, because choose implementation wisely based on language features, We saw that Java and Python use a completely different approach, the way they implement this pattern. Be aware of its drawbacks. Remember, always looking for what is the business purpose, what are the most important factors when you are implementing your application, and check if you want to use a singleton. Imagine that your code needs a lot of maintenance. There will be constantly refactorings on the code. Maybe avoid singleton on those cases, because you are creating coupling in a system that you don't want couple because you are changing too much. So it's an advice that I can give you. Consider alternatives like dependency injection for more flexible and testable designs. Okay, when you are using a kind of behavior singleton, of course, when it's about state, you have independence injection like Spring Boot ways to do it using beans, but you have to consider if you really want to go in that direction or not. So use it with caution and only when it's truly necessary, and I think it's a great advice. So thank you for watching this presentation. I hope that I brought to you new things about this pattern. Sometimes people think that they already know the pattern when they learn it from the code point of view, but I like to explain as an architect the more conceptual view about this pattern, so you understand what are the challenges, if you should apply it or not, what will be the trade-offs, what will be the why, what are the different approach in language, to consider which one to choose. I didn't say which ones for you to go. I just explained the advantage, disadvantage, the challenge, why one approach exists, why the other approach exists. It will be on you to choose the best one for your project. So thank you for watching this video. I hope you subscribe my channel. It will give me motivation to continue. Share my channel with your friends. Do some likes to motivate me, and I hope to see you in my next video.